Before we began filming this episode, we searched on LinkedIn for Android developer jobs from different parts of the world. We found that many companies require applicants to have experience with one of the following patterns: MVVM, MVI, MVP, or clean architecture. So, what are these patterns? When should we use them? And what are the differences between them?
These architectural patterns often cause a lot of confusion, and I say this from personal experience. But today, we're going to clear up that confusion together. Let's get started. Let's start from the basics. Application architecture. It simply refers to the way an application's components such as UI, data, and logic are organized to make the app easier to understand, develop, and test, as well as to reduce errors and make maintenance and scaling simpler. This is a very fundamental piece of knowledge.
An application's architecture generally consists of two main parts, layers and patterns. The first part, layers, which describe the structure of the app and how responsibilities are separated. There are three primary layers: presentation layer, and domain layer, and data layer.
Let's start the explanation from the presentation layer. This layer is responsible for displaying the application's data on the screen. It consists of two main parts: UI elements and StateHolder. UI elements, the visible components such as buttons, text fields, and other input elements. StateHolder, think of it as the small brain behind the screen. An object that stores the information needed by the UI, updates it when necessary, and sends it to be displayed to the user.
Let's talk about the data layer. This layer contains the business logic, which gives the application its actual functionality and value. It defines the rules and operations that determine how the app creates, stores, and modifies data. The data layer usually consists of repositories, and each repository can include multiple data sources, such as a database or a network API.
The middle layer is domain layer. This is an optional layer used to encapsulate complex business logic. If your app logic is simple, you can skip this layer to keep your structure clean and straightforward. Now that we have the two essential components of any application, the presentation and data layers, what comes next? The second part of an architecture is what we call the design pattern. This is where those well-known architectural patterns we mentioned earlier come in: MVVM, MVI, MVP, and clean architecture.
We first need to understand their components and how to use them. So, let's break down MVVM. It is an acronym for M for model, V for view, and VM for view model. Let's start with the simplest, view. It refers to what the user sees and interacts with, such as the screen or buttons. This means it represents Jetpack Compose or the code responsible for building the user interface, adding texts and buttons. In the layers or components of an application, the view is part of the user interface layer, representing the section known as UI elements. The other part of this layer, we'll return to it shortly.
Before defining the model, I want to clarify a particular point that is rarely discussed. When looking at these architectural patterns, you should know that they did not all appear in the same time period. The MVC pattern emerged in the 1970s as the first design pattern for graphical user interface applications in the Smalltalk programming language. Its main goal was to separate business logic from the presentation layer, making it easier to update the interface without affecting the underlying data. This was long before Android existed, and even before modern architectural layers, that is presentation, domain, and data, were introduced. Therefore, this pattern does not fit well with modern applications, and is rarely mentioned in job requirements today.
By contrast, the MVP or model view presenter pattern is also considered somewhat old, having appeared in the 1990s, and it became popular in desktop applications and early versions of Android. MVP was introduced to solve the controller problem in MVC, by allowing the presenter to fully control the flow of data between the view and the model. As for clean architecture, developed by Uncle Bob, it is entirely different from the others. Its goal is to make the application consist of independent layers, so that inner layers do not depend on the outer ones.
We are now taking an overview of what these architectural patterns are. Our focus will be on MVVM and MVI, since they are the most commonly used today, while we will briefly mention MVP and MVC only to highlight certain differences and clarify common misconceptions. The first point of confusion often relates to the definition of the model. The term model is used frequently in programming, and it can be confusing because its meaning changes depending on the design pattern being used. At first, I thought there was only one definition of a model, but it turns out that its definition varies depending on the architectural pattern. Let's start with the oldest one, MVC. In this pattern, the model represents the data itself and the application's logic, such as the database, network, or computational processes. Most developers have likely encountered this definition before. In the MVVM pattern, however, the model is defined as the part responsible for representing the data and its related logic, such as fetching it from a database or a network and processing it before sending it to the presentation layer. Notice that we said fetching the data, which means the model in MVVM does not store the data by himself. Instead, it retrieves it from the data layer. Here lies the difference from the older MVC model, where the data layer was not separated. In the MVI pattern, the model represents the current UI state, in other words, all the data that describes how the screen should look right now.
Let's see how model looks in Android code. Starting first with the MVVM pattern. In this line, we define a simple class named user. It represents a user and contains only one variable called name. However, when defining a model in MVI, we are not defining a user, but rather a data class that stores the state of the screen. A data class in Kotlin is a special type of class used when we only need to store data and don't need to write any logic or functions inside it. It is commonly used in the MVI pattern to represent temporary or constantly changing UI data. Kotlin automatically provides useful functions for data classes, such as copy, equals, and toString functions. Another key difference to note is that in MVI, the model represents the UI state itself, and therefore belongs to the presentation layer. Whereas in MVVM, the model is part of the data layer.
The most important distinction, the intent in MVI. An intent represents the user's intention, the action that occurs when the user interacts with the interface, such as pressing a button, entering text, or selecting an item from a list. In the MVI pattern, every user event or intent is sent to the view model, which then responds by producing a new state, a new representation of how the UI should look. Yes, MVI includes a model, a view, an intent, and a view model, but its view model works differently from the one in MVVM. So what is the view model in MVVM? The view model is responsible for the logic that connects the view or UI and the model or data. In other words, it receives events from the UI, fetches or updates data through the model, and then prepares the data in a form suitable for display on the screen. Remember when we said there is a small brain behind the screen? That's the view model. It acts as the StateHolder, sitting right behind the UI components. Now, let's take a look at a simple MVVM example. We have the view, in which the username is defined through the variable view model, which was declared as a parameter. Then, there is the definition of the screen elements, a greeting text that includes a variable representing the user's name, and below it, a button that switches the registered name to another one. When the button is pressed, the view model sends the command to the model to update the variable's value. As we can see, the first thing defined in the view model is the repository. This line defines an internal mutable variable, mutable state flow, that stores the current username obtained from the repository. In other words, _name represents a state that changes whenever the username changes. One of the key characteristics of mutable state flow is that it can hold a value, while also notifying any observing part of the code whenever this value changes. Therefore, we create another version named name that only observes _name, which will be used by the view. This way, the view can observe changes to the username without having the ability to modify it directly. Only the view model can update its value, ensuring data safety and consistency. Change name function is called when the user presses the button. First, it notifies the repository to change the username. Second, it updates the new value of _name, which automatically refreshes the user interface since it observes this variable. Here, we created a user repository class responsible for storing and managing user data. It contains a variable named user, initialized with a default value, and defined when the view model is created, which in turn creates the repository. getUser function returns the current user, and changeUsername function changes the username. It takes the new name and creates a new user instance with the same previous data but a different name, using the copy function. Finally, the model represents the object that stores the data used by the user interface. Of course, in larger applications, the process is more complex. The app might be connected to a full database or a remote server through an API to retrieve and update data.
In the code for the MVI pattern, we can see structures that closely resemble the previous pattern, MVVM. Inside the view, we define the view model, where we also define the screen state. This state represents the current condition of the UI, such as the displayed name, loading status, or errors, and does not come from a database. Next, we define the screen elements, just like in the previous code, a text showing the name and a button to change it. Since an intent represents a user event that informs the view model what action to take, it is implemented as the onChangeNameClicked function. Typically, a specific intent object or sealed class is defined in full MVI applications. In larger projects, an intent is usually defined like this. Sealed class have object inside of it. Another important aspect of MVI is that everything displayed on the screen is represented inside a single object called state, which describes the current layout of the UI. Then we move to the view model, where we define the screen state variable. This _UI state variable acts as a bridge between the presentation logic and the user interface. Whenever a change occurs, like button click or new data arrival, we do not modify the UI elements directly. Instead, we create a new state instance representing the new UI layout. Then, the view automatically re-renders according to the updated state. Again, the key difference is, in MVVM, the model represents the data source, like a database or API. In MVI, the model represents the UI state itself, the interface's data that updates with every user interaction. Thus, MVI focuses on full state management, making the UI a direct reflection of the state, which simplifies tracking changes and debugging.
It's my time to ask the big question. When should we use MVVM and when should use MVI?
Good question. MVVM is best suited for regular or moderately complex applications. When working with external data sources, like a database or API. When events and interactions are simple. It works excellently for most commercial or everyday apps. Example: an e-commerce app, a chat app, or an app that displays a list from an API with a few buttons.
When to use MVI? It's best suited for large or very complex applications with intricate interfaces and interactions. And when there are many events and frequent state changes, or when you need precise state tracking to know the exact condition of the screen at each interaction. It is suitable for complex apps like Gmail, YouTube, or Instagram.
When applying for an Android developer position, this knowledge gives you a general idea of the types of applications companies want to develop, based on the requirements they list in job qualifications. One more important point: it's time to announce our comprehensive design patterns guide, a simplified presentation explaining all design patterns from MVC to MVP. You'll find everything you need to know clearly and visually. You can access it on our Patreon store, which helps you level up and also supports the channel to keep producing content.
We hope this helped clarify the complexity surrounding these design patterns. If you're interested in a full video on clean architecture, let us know in the comments. If today's episode helped you even a little, then hit like, Leave a comment and let us know you learning. Next time.
We will level up.